Welcome to the Matplotlib series. This is the first and the most important tutorial as we are going to understand the basics of this library. The main goal of this video is that you become familiarized with the different methods that Matplotlib provides to create a graph. And to do that, you need to know what a Matplotlib graph is. Every Matplotlib graph is composed by three elements: a figure, which is the object that we can resize and interact with the plot, the plotting area, which is also called axis or subplot, and finally the plot itself. And the way it works is the following. A figure can contain one or multiple plotting areas, and each plotting area can contain one or multiple plots. In this case, we have a figure with one plotting area, and within this plotting area, we have 4 plots. If you understand that, customizing graphs is gonna be a piece of cake for you. Let's move to our Jupyter notebook. Matplotlib does not come built-in with Python. We need to install it. If you don't have it already, open your terminal and type python -m pip install matplotlib. Then we can start. Okay, we first have 2 special commands. The first one is only to allow plots inline so that we don't get a pop-up window. And the second block of code is only to help me to explain you how Matplotlib creates a graph. You don't need to use it. Then comes the most important one, which is importing the libraries. When using Matplotlib, you'll be mostly using a submodule called Matplot. And Matplot is a collection of functions that help us to create graphs. Then we are also importing NumPy. And finally, I have this last block of code which changes the default format of a Jupyter notebook to avoid blurry graphs. What that does is every time I create a graph, I generate a vectorized graph so that you can see it properly in the video. Let's start talking about the first method to create a graph using Matplotlib, and that's called an implicit method. First, let's create our data. I will create my X array. Let's use linspace. Numbers from -1 to 1. How many numbers? Let's say 50. Then we can create our Y array, and that's gonna be X power 3. Alright, this is our data. And to plot this data use the implicit approach, we only need to call Matplot plt dot what we want to do to plot. Then we provide the X and Y array. And now, if you want to show it to the user, we need to use the show function, plt.show. If I run it, we get the representation of this data as a line plot. And notice that I did not have to create the figure or the plotting area manually. I just called the plot function from Matplot and everything was created automatically. And this is the reason why this method is called implicit method. And what about the explicit method? Let me show you. In the explicit approach, we need to create each element of a Matplotlib graph manually. And the very first element, as you saw, is the figure. And to create the figure, we just type plt.figure. And as I mentioned, when you create a graph, you need to show it, right? Then I'm gonna call the show method. If I run it, we have the figure. But now, once I have a figure, I need to create my plotting area. Let's do that. The figure function from Matplot will return an object that I'm gonna assign to a variable called fig. Now, on this figure, I want to add a subplot. If I run this code, we see that our subplot is created. Now, there is only one step missing, which is plotting the graph. Then, I'm gonna assign this object here to a variable called axis, in this case just a x. And now, on this axis, I want to plot x and y. If I run it, we finally get our plot. If you remember what we just talked about in the beginning of this video, it makes completely sense. We first create the figure. On this figure, we add a subplot, which is also called the plotting area. And now on this plotting area, we start creating our plots. And maybe you are thinking, why should I waste 4 lines of code for something that I can do in only 2? The biggest advantage of this approach, or the implicit approach, is the fact that we only need a few lines of code to create a graph. However, it is less flexible than the explicit one. And later, when we start talking about very complex graphs and figures with multiple plotting areas, you understand that having the control of the figure, plotting area, and the plot itself is much better to maintain and to customize our graphs. I wanted to show you both approaches, but from this point on, I'll be only using the explicit method, as I want you to have full control and to be able to customize your graphs properly. Okay, and just one parenthesis here. Normally in the Jupyter Notebook, you don't have this option of interactiveness. I can zoom and I can pan, I can do whatever I want. And this was only possible because in the beginning of this Jupyter Notebook, I had that second block of code. Now I will run this Jupyter Notebook without running this block of code. Then we will see only this type of graph inline. Then let me do that. I'll go to kernel, restart clear output. Yes, I want to restart everything. Then I go there, say, okay, I want Matplotlib inline. Now we'll no longer run this code here. Then we import the libraries, we get high quality graphs, we create our data, run the implicit approach, and finally run our explicit approach. And again, from now on, we're gonna only consider the explicit approach. Okay, let's start customizing this graph. I will just copy this code, put it here so that we have like a nice document later. I run it again. And now I'm gonna tell you how to create titles and labels. And we do that with this idea of setters. And setter is basically, we have our plotting area, which is AX, because I call that as AX here. And now I say set title. And here you just give a string. I say explicit method. If I run it, we get our graph. And to add label to the X and Y coordinates is the same. Just call the axis or the plotting area and then say set X label. And now you also give a string. Then let me create the label for the Y coordinate, Y label. Then just change X by Y. If I run it, we get the title and the labels. And if you want to set the limits of the X and Y coordinates, we use a setter again. We say AX dot set X limit, and our data goes from -1 to 1, and same holds true for Y limit. Then we change it. Now our plotting area goes from -1 to 1 in X and also -1 to 1 in Y. And what if you want to add another plot? This is very simple. We just call again our plotting area, then call the plot function, and let's just switch or flip this graph. Then I give Y and X. Now we have two plots, but we have no idea what is what, right? Then let's add a legend. How to do that? We want to add a legend in our plotting area, just called legend. One way to add legend is manually. So you can just create a list, right? And then you give two elements. The first one belongs to the first graph. I'll make a mistake here on purpose. And I'm gonna call the first plot as orange graph. And the second one as the blue graph. If I run it, and now you can see the inconsistency, right? The blue plot has the legend orange, and the orange plot has the legend blue. So if you want to avoid this kind of mistake, what you can do, we can use the label parameter. And this parameter goes inside the plot function. Let me then add on both all together. Then I say label equals to. Now we give a string. The first one, let me just call graph1, and the second one, graph2. If you provide the label parameter to the plot itself, now you only need to call the legend so that when you run it, each label will be assigned to the correct plot. And the last piece of information I'm going to share with you in this video is how to add a grid. We know that both plots intersect each other in the origin, so the 0, 0. But if you want to have a better orientation of the plots, we can add the grid. We just type AX, then grid. We have our plot, we have the legends, now we have the grid, and it looks like a graph. And now that you understand what a matplot graph is and the methods available to create it, we can start going deeper to graph customization. This is gonna be the subject of the next video. We'll start from where we left off here and make this graph a bit more interesting. You will also have 2 or 3 challenges to solve using the knowledge you acquired from the first and second video of this series. Thank you very much for watching and see you in the next one.